Analyze the combustion reaction. The original compound contains only carbon, C, hydrogen, H, and nitrogen, N. When it is completely burned in excess oxygen, O2, all of the carbon in the compound is oxidized to carbon dioxide, CO2, and all of the hydrogen is oxidized to water, H2O. Calculate the moles of carbon, C, in the compound sample. Find the moles of CO2 produced using its molar mass. Approximately 44.0 grams per mole NCO2 is equal to 44.0 grams of CO2 over 44.0 grams per mole equals 1.0 moles of CO2, since each molecule of CO2 contains exactly one carbon atom. The moles of carbon atoms in the original compound must equal the moles of CO2 produced. NC equals NCO2 is equal to 1.0 moles of C. Calculate the moles of hydrogen, H, in the compound sample. Find the moles of H2O produced using its molar mass. Approximately 18.0 grams per mole in H2O equals 45.0 grams of H2O over 18.0 grams per mole equals 2.5 moles of H2O, since each molecule of H2O contains exactly 2 hydrogen atoms. The moles of hydrogen atoms in the original compound must be twice the moles of water produced. NH equals 2 times NH2O equals 2 times 2.5 moles equals 5.0 moles of H. Determine the molar ratio of carbon to hydrogen, C. H. The simplest mole-to-mole ratio of carbon to hydrogen in the starting compound is ratio, C. H, equals 1.0. 5.0. Evaluate the options for a matching C-H ratio. An empirical formula represents the simplest whole number ratio of elements in a compound. Therefore, any possible empirical formula for this compound must exhibit a carbon-to-hydrogen ratio of exactly 1 to 5. Examining the options, only CH5N, option B, has a C-H ratio of 1 to 5. This matches the official answer key. The correct answer is option B, CH5N.